This section is about unions and intersections. Okay, this is the real definition for a union. A and B denote two sets and are represented in the Venn diagrams by circles. The operations of union and intersection are demonstrated in the diagrams by means of shading. The union of A and B denoted A union B, that little symbol stands for union, is the set all x such that x is an element of A or x is an element of B. That is, an element x is in A union B if it is in the set A, the set B, or both. Note that the union of A and B contains both individual sets. Okay, this could be just a lot of mumbo jumbo for a lot of people. So let's make it really clear. First of all, a union of two sets is denoted by the word or, and it means everything in both sets. Even though this little bit in the middle is contained in both sets, you only count it once because it is in the union of those two sets. I always think about a marriage, at least a 1950s style marriage. You know how whenever in the 1950s, I'm making the joke here by the way, people got married and everything that belonged to one of them also belonged to the other. So when they get married, they just put everything together in one house and it became theirs instead of mine and yours. Well, a union is like that kind of marriage. Everything in one gets thrown in with everything from the other and they become one big set. That's what a union is. So what about an intersection? The intersection of A and B denoted A, intersection B, that little upside down U, that stands for intersection, is the set all x such that x is an element of A and x is an element of B. That is, an element is in X intersection B if it is in both A and B. Note that the intersection of A and B is contained in each individual set. An intersection is just exactly what it sounds like. It's where they cross each other. The intersection is denoted by the word and because every element that's in the intersection must be in both sets. See this little space in the middle right here? Those are the only elements, although you can't see any right now, but those would be the only elements that are contained in both A and B. That's what intersection means. Okay, let's see if we can work on some of these. I need to change my color really fast. Let's try this color, see if it works. What I want to do is graph each of these intervals separately and then do what the union or intersection symbol tells us to do. So I know I can't draw very straight lines on this thing, so bear with me here. Alright, the first one goes from -5 to 5 and the second one goes from 1 to 7. So what I want to do is start at -5. I don't have enough room, do I? You get the idea. Okay, so from -1 to 7. And what I want to do, let's see. If I can delete that one, we'll just use one number line for now. It'll still work either way. Okay. So -5 to 5 is from here, -5 to 5, and you include everything between them, including the endpoints. Okay? Then you have 1 to 7. So 1 to 7. You include the 1, but you do not include the 7. Okay, hopefully you can see the difference in those two colors there. Okay, this is to find the union of those two sets. Remember, the definition of union is everything that is contained in both of them together. You just throw everything together. Well, if you do that, it would start from -5 and it would stop at 7. Notice how I don't include the 7? That 7 is not included in either of those two sets. That means our interval is from here to here. So the answer to this one would be -5 to 7. Does that make sense? Okay, what about the union of those two sets? I'm sorry, the intersection. This one here. The intersection is only the parts where they touch or where they cross. Well, look at our picture because we have the same two intervals. So just look at a picture that we already have. The intersection would be everything in here. So the key is, do I include the 1 and the 5 or do I not? Well, let's see. We know we have a 1 and a 5. Is 5 included in both sets? This one stops at 5, but we have a bracket. That means it is included. We know it's inside this one, so we do include the 5. Remember, it must be included in both if it's an intersection. How about the 1? This one, -5 to 5, 1 is definitely included. How about this one? The 1 is also included because we have a bracket here. So the answer to the intersection of these two sets would be 1 to 5 closed. Okay, let's try a couple more. I have no idea what color will work. We'll just try this one and see if it works. Okay. Alright, -2 to 6 and then 6 to 10. So I need to go all the way from -2 to 10. -2, -1, 0. Okay, so the first one goes from -2 to 6, and we do not include those endpoints. -2 to 6. Everything in the middle of those. Okay, the next one goes from 6 to 10. Let me use a different color here. So 6 to 10, we don't include the 6, but we do include the 10. Okay, this is asking for the intersection of those two. Well, do these cross anywhere? They don't, right? So since there is no solution for this, we actually call this the empty set. It's a 0 with a line through it, or you can just write these wiggly brackets with nothing inside. Keep in mind, you don't want to do this. This is not correct because this set, these little squiggly lines tell me that it's a set. This set contains an element, and that element is the symbol. So this would not be the correct way to go. Please don't do that. You want to either write it as the empty set symbol or a set that is actually empty. Alright, so let's look at the next one. We need to go from -infinity to 10, and then from 7 to infinity. Ooh. So let's see, let's just do this. Let's do 7 here, and let's do 10 here. Alright, -infinity to 10 looks something like this. Remember, you don't include the 10. And it's everything up to that point. -infinity to 10. Now what about the next one? The next one says 7 to infinity. So you do include the 7 and then you go this direction. Okay, is this asking for a union or an intersection? It's asking for a union. That means we want everything in both sets. So if this one starts at 10 and goes forever in the negative direction, this one starts at 7 and goes forever in the positive direction, don't we actually include everything on the number line? So if that's the case, our answer will be negative infinity to infinity. It is the entire number line.